Hello, today we will be studying control flow graphs or CFG of computer programs, especially as it relates to system testing and verification. So let's begin. So the textbooks on software testing and verification describe algorithms and techniques for graphs and data structures at great length. But I've seen many students not completely sure as to what these graphs have to do with the actual software that needs to be tested. In other words, they wonder how studying graphs, nodes, and arcs help in testing actual software systems written in programming languages. After all, no one is going to ask you to test a bunch of nodes and arcs. They will give you some software systems to test. So, what's the point? This is a valid question. Let me try to address this doubt. A graph or a CFG control flow graph is actually a representation or a model of an actual computer program. Let me illustrate this with a very simple example. Let's say we have a store that gives a discount of 20% if you make a purchase of $50 or more. So here is how you will implement this payment system in a programming language like Java, C or C++, etc. So here we have a variable uh, total purchase, and we are for let's say we made a purchase of $65. So we are setting it to 65. Then we are testing that total purchase value if it is $50, if it is indeed $50 or not. Uh, so if it is indeed more than or equal to $50, we are reducing the total bill, which is total purchase, by 20% by you making this computation. We are reducing it by 20%. And finally, we make a payment of whatever the final value of total purchase is. So if you had made a purchase of $65, then by making this applying this discount, you will be paying only $52, not 65. But in case this condition is not true, let's say you made a purchase of, let's say, only $30, which is less than $50, then we don't make this adjustment. We make whatever payment of whatever the total purchase is. So this is how you will implement this payment system in a programming language. So, so here we have the same program again. It is where the total purchase price is set equal to 65. And so here we are representing that computation in the form of a graph. So we have a node where we are setting this total purchase is equal to 65. Uh, this is a computation. And then uh, we test whether a purchase is $50 or more or not. If it is indeed more than or equal to $50, then we make the second computation. We reduce, apply a discount of 20% on total purchase. And once we've done that, we go to the third step, where we make a final payment of uh, payment which is equal to the current value of total purchase. But what will happen if a if we did not make a purchase of $50 or like less than $50? So in that case, we uh, uh, we we don't apply any adjustment to total purchase. We we immediately go to the payment section, and we make the payment of whatever the value of total purchase is. That is in case this condition is true. that is the total purchase is less than 50, then we follow this path. But if it is more than or equal to 50, then we follow this path. So these are the two paths that a program can take. So this is how we represented a small uh, program in the form of a control flow graph. They represent the same computation, but in a different representation. So that should answer the doubt that why we should study the graphs, nodes, and arcs, etc., when we have to test actual programming systems, software systems. So here we have a software system, and here we have the uh, corresponding graphical representation of the same system. So uh, that is the answer to that doubt. So now we have seen how the graphs represent the software systems. Well, let's see what are the rules for such graph, such representation. So the very first thing is the nodes represent actual computations. These nodes, which are shown in the form of circles. So we have the node number one, which where we are setting the total purchase equal to 65. This is a computation. And at node number two, we are applying uh, a discount of 20% on the total purchase. At node number three, we are setting the value of final payment to current value of total purchase. Uh, so these are the three computations that are happening in this software system. But whether all three will computations will take place or only some of them will take place, that is represented by arcs. So the arcs in the system, like this arc, this one, and this one, they don't represent any computation. They only represent conditions. So, for example, this arc represent the condition that the total purchase is more than or equal to 50. There is no computation going on here, only a comparison, and a condition is getting tested. Same way, this arc represents uh, the condition that total purchase is less than 50. Again, no computation, only a condition is getting tested. Um, and so where our computation starts from? It starts from an initial node, and initial node is identified by an arrow, which is by like a standalone. It is not coming from any other node. So, for example, this arrow does not emanate from any other node. It is uh, coming from nowhere. So that represents the initial node. So initial node where the computation is begins is node one here. If there was this arrow was here, for example, on node number two, then this would have been the initial node. But in this case, node number one is the initial node. Same way, the final node are represented by double circles. So node number three is represented by double circle. So that is the final node. The computation stops at this, the program stops at this computation. So this is how we represent uh, the computer programs in the form of control flow graphs. Uh, we have seen a very simple example of a simple if condition, and that is represented by the control flow graph shown here. Uh, but there are more programming structures, control structures, and they will be represented by different kind of graphs. So we will be studying them in other videos. But This should at least clarify some to some level the doubt that why the value or utility of studying graph structures in for in the when we are studying software testing and verification. Uh, so this should we will be looking at other videos in a later other structures in later videos. So keep checking this channel, and if you have any questions or doubts, don't hesitate to ask in the comments section below, and I will try to answer your questions as and when I get time. And thanks for watching, and see you in the next video. Thank you very much. Bye bye.